All right, let's finish up these last two problems here. So for part C, when we go through this here, what we're going to see is this. We should identify, hopefully, that this is a product rule. How do you identify product rules? You have the some function of x multiplying some function of x. So you can see I've got something with x's times something with x's. There's your product rule. All right. And as we hopefully remember, the product rule says if you've got some function times another function, u times v, that derivative would be, so the derivative of that function would be u prime v, so take the derivative of the first thing, leave the second thing alone, plus u v prime, leave the first thing alone, first factor alone, times the derivative of the second. All right, so here we go. The product rule here, actually, I'll just make this here. All right, so derivative of the first thing, the yellow function. So therefore, f prime would be the derivative of that. Well, that's we're kind of used to those hopefully at this point. So that's 2x minus 1. Leave the second function alone. Leave the second factor alone. Plus, now leave your first factor alone. So x squared minus x minus 3. Take the derivative of the next function. Well, that's an exponential base 12. So hopefully we remember the exponential base 12 derivative would be the same exponential times the natural log of the base. Let me turn that up. There we go. Okay, so now next problem. This is one just to kind of reiterate that you can have all sorts of fun. You can have a function times another function that has a chain rule inside of it. So therefore, we have to mix and match. We're going to not only do product rule, but we're also going to chain rule in one problem. So again, derivative of the first. So derivative of e to the x is e to the x, because it's an exponential function, times the natural log of the base. But the good news, natural log of e is just 1, so we typically don't write that. So therefore, the derivative of e to the x is e to the x. Leave the second function exactly how it is. Leave it alone. Okay. Plus, now leave your first function alone and multiply it by the derivative of the next. Well, the derivative of natural log is 1 over the junk. So we've got x to the 5th minus 8x as our junk. Then, so now using our chain rule kind of notation I show you is, all right, we've done the derivative of the natural log, but we haven't done the derivative of the x to the 5th minus 8x. So times the derivative of that. So that would be 5x to the 4th minus 8. And there you go. That would be the end of our derivatives. Now, there's going to be one little bonus problem here for everybody who's watching. All right, here's the bonus problem. If I gave you f of x equals e to the 3 minus natural log of 4 and said, find the derivative of that. Well, it's quite simple. I don't have to use the exponential rules. I don't have to use natural log rules. Reason why? Do you notice that there are no variables? If there's no variables in a problem, it's a constant. So therefore, the derivative is 0. So I just want to remind you guys, don't get fooled by e to the something or natural log of something. If there's no variable, there's no derivative. Well, there is a derivative. The derivative is just 0. Okay? Best of luck.